Hello all, Hello all, welcome to the session, and we are going to talk about the course as such. What all things we are going to cover in this particular course, and then we will start off today's class. We will start with few of the topics, and we'll see how much we are able to cover. But at a high level, with these are the stuff that we are going to cover. What we will this course is first of all called as network mastery, and what we do is we are going to master the skill of designing, configuring, and troubleshooting computer networks. So this will definitely include the entire CCNA syllabus, but it also will include N plus syllabus. It also will include security plus syllabus. So it's not a very specific certification only, but you will cover everything that you want to learn in the certification and beyond. Because one of the main reason I have started this particular course is because the certifications are important, please not get me wrong, but that is not enough for you to land in a job, perform in an interview. Even if you get into a job, it is not enough for you to perform in the job that you actually got. So and then we need to have the knowledge a little beyond the certification, but we will cover definitely the entire syllabus that a certification actually asks for, but we will cover beyond that, so you are well prepared for your session. And here is the registration link, and then please register if you are actually interested in. And this cohort is going to start in June. The next cohort is going to start in June, so feel free to sign in if you are interested. So let's first look at the outline of the course. What we're going to start is with an introduction to network, where we will see what is computer network, a little bit of history. We will take an analogy on to understand how computer network works. Then we will come to different types of network, or different types of devices that actually builds this particular network. We'll talk about hubs, switch, routers, load balancers, what are the different components on each of those devices. Then we will get into the chapter 3, where we will talk about the standards that actually makes these computer networks, right? Different set of standard, why that standard has come into picture. Then we will come to and then see different types of network, like there is a small network which is called as LAN. There is something called MAN, which is metropolitan area network. Then we will see WAN, and majorly three different types of network. And then we will have a deep dive on into the TCP IP layers. We will also see the OSI layers. We will talk about physical different layers and how they are structured, and how they are structured, and how they are structured in a certain way. We will also have a revision on the WAN side, and then we will do a deep dive on the network layer. Now, the three layers that we will focus majorly on this course is the network layer, transport layer, and the data link layer. So these are the three layers where things are actually most of the routing related stuff which we need to do, network related stuff we need to know more, is in these three layers. And then we will have a little bit more into the need of routing. We will see how the IP headers are. How does a host name, like when you type google.com, how does it really work under the or how does it get converted to a language that these devices in the network knows. All those stuff will be covered here. Now, there are two protocols that you need to really master at the transport layer, and that is TCP and UDP. We will go deeper into the packet format, what the port numbers is, how is it relevant, and stuff like that. Also, another protocol that you need to master is IP. And there is one more where you will be mastering in the data link layer, which is the Ethernet packet. So those three, Ethernet in the data link layer, IP in the network layer, TCP and UDP in the transport layer. These are the three or four protocols that you will master in this one. But we will definitely touch upon other protocols, like how do a PC get an IP address, how do the host name to IP address conversion happens, and all those stuff will be covered. Then we will do a complete flow. We will do an exercise where we will build the network first, and then we'll configure the devices, and then we will make sure and we will show how the packet goes from starting from the source PC all the way to the destination PC and all the intermediate devices. How does this packet goes from one end to other end? That's what we're going to cover once we reach chapter 8. And then another very important subject, this is one of the major important subject in CCNA as well, which is subnetting and IPv4, where you will know if you are given a network, how do you make it into smaller chunks. Let's say you are a network administrator and you have a small company, and then you want to distribute your network distribute your network subnet basically into multiple small subnet, and then create how do you build and design your network. And we will have few subnet exercise. We will also learn what is CIDR, which is classless interdomain routing, and then we will understand what a subnet mask is and why is it needed. Then we will cover as a technology called as network address translation. Like you might have heard about IPv4, IPv6. So why did in between IPv4 and IPv6 there was a technology called NAT, which is network address translation, how it has actually worked over the period of time, and what is its relevance. Then we will get into the more of the routing related stuff, right? We will configure the router, and then we will show you how the routing actually works. And then there are different types of routing. One is static routing and dynamic routing, and you will be mastering these two protocols, RIP and OSPF, in depth in this particular course. It's not only the things that have been covered in CCNA, but you will go in deep into different types of protocol, different elements of these protocols. And finally, and then we will get into BGP. You will not be mastering BGP, because BGP in itself is a course that we will need to do, but you will get to know enough of the BGP and how BGP works. We will go into the packet structure, and then we will see how other elements actually works in BGP. There is something called internal BGP and external BGP. Basically, BGP is a protocol that is used extensively in the service provider networks. We will see the application of those things as well. And then we will talk about the introduction to IPv6. I have touched upon that when we talk about NAT, we will definitely talk about IPv6 and why and what is the need of IPv6, when was it discovered. And finally, we will end up on the chapter 20, where we will talk about some of the troubleshooting steps and tools. So that's how the course is actually structured. And then let's get started. So let's get started with the very first chapter, that is introduction to the networking. Now, starting with that, the very basic question of why we need a network, it is pretty simple, right? I mean, you have, as users, we are actually having devices, which includes, a laptop, which includes PCs, which includes your phones, and you will be accessing some contents in the internet, and those contents in the internet will be, most of the time, it will be placed in one of the servers, and then you are trying to access those servers. Or it could be something which has been placed in your friend's PC, and you're trying to connect between your PC and your friend's PC. Maybe you are playing a game, and then you'll have an Xbox or some of the gaming console through which you will be accessing the gaming server. So it could be anything, but fundamentally the thing is that we are trying to connect between one device to another device, and that one device and another device will vary depend on what you're trying to do. If you are trying to access a social media, that means you are going to access a Facebook servers or any of the social media servers. If you are accessing Facebook, that means you are accessing the Facebook servers, versus if you are trying to do a game between your friends, that means you are connecting to the servers, and servers are connecting back to both of you. So in either case, the fundamental thing is that what we're trying to do is to connect between two devices. So a network is actually needed to make sure that there is a proper connectivity between a requester who is actually trying to request something, and a provider who is actually providing those contents, right? That very high level in layman language, we can actually say that. Now, when you connect between two devices, one of the most important thing is that we need to make sure that one is that it should be faster or faster enough depending on the application. For example, let's say you are playing the game, and when you're playing the game, the speed at which you will need to connect between your friends, that should be very fast. You cannot take that, let's say you are playing a shooting game. That means there should not be too much of delay between the content that has been provided between you and your friend, because then the gaming will not really work. Or another example is you are actually watching a movie, right? I mean, you are watching a movie, and then in the real time, and that means, or let's say you are actually in the Facebook, somebody is going live, and then you are consuming those live streaming content. You cannot have a delay in that too much, because then whatever the content that has been produced there, it's not a live content that is getting consumed. So depending on the content that is delivered, one thing that a network should make sure is the speed of the delivery of packet, speed of the delivery of the content. And another thing is it should be secure, because the most important thing is, let's say you are doing a transaction which includes your credit card or something. That means your transaction has to be secured. So security is another aspect. There are multiple other aspects as well when you consider different parts of the network. For example, when you are actually using a server will have a lot of content, and that we need to do a load balancing so that the load is not really heavy on a particular application. We'll get into the code nuances later, but at least right now you need to make sure, you need to understand that a network is an infrastructure that is actually allowing you to connect your PC to a server, to the server. And at least two minimum things: one is it should be faster, and second is it should be secure. Also, it should be reliable all the time. The network should be available for it to connect. Now, before we dive deeper into different components that actually builds the network, different devices that builds the network, what we're going to see is, let us take some moment to remember some of the greatest personality in the world who made sure that the concept of internet is actually available to the common people like us. So we are going to do in the immediately right now is we are going to learn a little bit of history and know some of the very important personalities who made sure the internet is built and built in a proper way, right? So let's go back to a little bit of history and then learn about few of the personalities. Whether you are a student, a practitioner, or somebody who is actually contributing to the computer networks, which is today's internet, which I mean by computer networks, whoever you are in whichever way associated to the computer network, I think you should know about some of the timelines in the history that actually made this amazing thing called internet. There are some of the incidents that has actually strived. There are a set of individuals who has this vision of creating this beautiful thing called internet, which is an essential need for humanity today. So I'm going to take you through some of those incidents in the history which actually triggered this amazing thing called internet and how it has been evolved. For sure, I will not be able to cover the entire incidents as such, but I'm going to cover the most important of the initial set of incidents and events, as well as I'm going to list out few of those great individuals who had this vision of building this computer system and what actually made this particular thing in reality. So it dates back to 1957 when Sputnik 1 was launched by Soviet Union. There was this Cold War between United States of America and the Soviet Union. And when this happened, the then President of United States, Dwight D. Eisenhower, who is the 34th President of United States, called an urgent meeting with all the brilliant minds in the United States. And they kind of brainstorm how we will be able to kind of bridge this particular gap on the technology. And as part of that, there was as a concept in 1958 February 7th, ARPA was born. It still was a concept on how to kind of connect the how to build this network of computers. And it was at the same time a MIT grad who was actually graduating in electrical engineering. His name is Leonard Leinwalk. I think it's pronounced as Leinwalk. He published a paper on packet switching. He got intrigued with computing, which was not a stream of study at that point in time, but he did his research on packet switching and how is it going to help the communication as such. And approximately in the same time, early 1960s, there was another gentleman called J.C. Lightrider. He came up with a concept called galactic network. Basically, what that concept was is that there will be individual systems connected, and then they will be sharing the data pretty much like our internet today. And that was the vision that Lightrider had. In the year 1962, the same individual, the same gentleman, J.C. Lightrider, became the first head of the computer research program in DARPA. And in the year 1964, Leonard Linerock published his book called Communications Net. Even today, I think this is available. It's one of the finest book. I think I highly recommend for all of you network enthusiasts to read about, which actually put forward the concept of this packet switching. Moving forward, in the year 1965, this was the first, very rudimentary wide area network that was implemented by Lawrence G. Roberts and Thomas Merrill, based on the circuit switch telephone system. And this particular experiment gave a clear indication of the need for the packet switching, which was published by our gentleman Linerock. And in 1966, Lawrence G. Roberts went to DARPA to develop the plans for ARPANET. Following, in 1967, Lawrence G. Roberts published the work on ARPANET, and in the year 1968, August, there was a request for quotation for packet switching interface message processor. By that time, it was very clear that we need a packet switching mechanism for a efficient way of communication. So what this interface message processor was, it is something that actually can collect these packets in the network and then kind of reassemble it and then send it to the host. A very, very a rudimentary system that can actually collect the packets and then forward it. That particular RFQ was won by BPN at the team headed by Frank Hurd. And these are the names that if you search, you will be able to get more detail about these individuals. In 1969, BPN installed this interface message processor IMP in UCLA. The first host was connected and the second host was in Stanford Research. This was a packet switch wide area network, and the first communication was actually done through the ARPANET. And by the end of 1969, there were two more nodes that were actually connected, slowly building our internet of today. In the year 1970, December, the first host-to-host protocol called NCP, Network Control Protocol, was actually developed by Network Working Group, and it was team headed by Steve Crocker. In the year of 1972, Bob Kahn demonstrated the ARPANET at the International Computer Communication Conference, ICCC. In 73, Windsurf teamed with Bob Kahn, detailed today's TCP/IP and how the communication, how the modularity has to be adopted in the internet architecture. And the first written version was published, and Windsurf chaired the International Network Working Group. And as we all know, Windsurf is known as the father of internet. This is a quick snapshot of what are events and who are the individuals that has contributed to this particular events. These are a few landmarks in the history that actually built this amazing thing called internet. I will be posting a PDF format of this. If you are actually interested to download it, I feel free to click on this particular link down here, and then please access those PDF, which can be handy. And it's very important for us to remember these great individuals, these visionaries, and believe it or not, we all, whoever you are, whether you are a practitioner, whether you are a student, whether you are somebody in whichever way you are contributing to this amazing thing called internet, I think we should be thankful to these great individuals who has made something which is an essential need for humanity today. Let us also acknowledge some of those brilliant minds in the internet. Brilliant minds who build this particular internet. So we have seen the the historic timeline, what all things happened that created this amazing thing called internet. But let's also take a few minutes to acknowledge and appreciate those brilliant minds. And then, so a few of the names are going to be repeating, but there are a few more names that at least we should know. There are many, many more, but at least these names we should know before we get into learning the network. So I'm that kind of person where I feel that we should know about the personalities, we should know the history before we go into and learning about the any of the topic for that matter, right? In this case it's internet. Just let's go through some of to know some of the personalities and to appreciate the effort of those brilliant minds behind the internet, those people, those visionary people who has actually put their effort to make this amazing thing called internet available to all of us today. Let's start with the 34th President of United States of America. His name is Dwight D. Eisenhower. When USSR launched Sputnik 1, it was Dwight D. Eisenhower who was the President of America, and then he called for an immediate meeting and brainstormed with some of the brilliant minds in the United States, and then they came up with concept called the ARPA, and ARPA was born in February of 1958. There was a MIT grad at that point in time in early 1960s, like 61, Leonard Linerock. He identified the importance of packet switching for the computer communication. At that point in time, it was the circuit switching, the telephone switching, circuit switching network, but he identified that packet switching is more important for the computer communication. It was about around the same time another gentleman named J.C.R. Licklider, he introduced the concept called galactic network. And the concept was that the nodes comes in the network together and kind of exchange the data and also run the program across the network, pretty much same as what we experience in the internet today. Lawrence G. Roberts, he joined the DARPA to develop the ARPANET, and Frank Hurt, he was a part of BBN to develop the interface message processor. What interface message processor was? It was the device that was able to reassemble the packets in the network and then forward it to a host. A very, very rudimentary switch product at that point in time. Very early in 1960s, this thing was actually developed. Steve Crocker, he headed the development of network control protocol, which is the first host-to-host communication protocol. Bob Kahn, again, he demonstrated the ARPANET in International Computer Communication Conference. Along with Bob Kahn was Windsurf, who joined and detailed the TCP/IP, and Windsurf chaired as the International Networking Group, Networking Working Group. Along with Bob Kahn, it was Windsurf who detailed TCP/IP, and he chaired the International Network Working Group. And as we all know, Windsurf is known as the father of internet. Let's take a moment to thank to all these amazing individuals, and then remember these folks before you contribute or you learn about networking. And let's be thankful to these brilliant minds who made this internet possible to all of us. So now, since we have covered the introduction to the networking, we saw a little bit of history, we saw some of the major important individuals, personalities that have made this amazing thing called internet available. It's time for us to be part of it. It's time for us to understand each component separately, each component one by one, and to understand how this is being built and what you would need to learn, what you would need to understand the technicality of this internet. You need to know how you become a network specialist and then build your career in the networking. So we will start with the components that actually build the internet. There are different things like hubs, switches and stuff like that. We will get into that one by one right away. So this entire network, which we represent just as a globe or something, is actually built by different types of devices. In this video, what we're going to understand and identify is what all are the different types of devices that are needed for building a network. And it really depends. It depends on the need of the network. It depends on the need of the user. It depends on various factors that we employ different types of devices here. And there is a variety of devices that actually makes this network up and running, and at the same time there are devices that are actually making it secure as well. So we are going to go in depth on each of those devices and how these devices come together to build the network and secure the communication that is actually happening in the network. But before we go into that, in this short video, that what we're going to see is what all are the factors that really drives what is the device that needs to be selected. The selection of the device itself is driven by a set of factors. And now we are going to see what all are those factors in this video. So let's get started. The first part or the first factor could be, how far is the endpoint? For example, let's say you are in a room and you are having a laptop and you are sitting along with your friend and you want to communicate with each other. You just need a cable for you to connect between, or it could be a Wi-Fi access point, and we are going to go over each of these devices. You might have heard of these devices, but you might have heard of these devices as a end user, right? I mean, as a user, you might have heard of the devices. You might not have, as a student or say a network engineer or an administrator who actually builds this network and maintains this network. He needs to look at these devices in a separate lens altogether. So we are going to get there, but do understand that how far the endpoints are, the distance, the geolocation of two endpoints that are trying to communicate with each other. Depending on that, you will have different devices. If you are in a room, you will use a Wi-Fi or a cable, or you may use something called a hub or a switch. If you are in two different continents, then there are multiple devices that are actually coming into play. It will start with your Wi-Fi router or a switch, and then it will go all over the way to tier 1, tier 2, tier 3 ISPs, and then it actually gets hand off at the same other end, whom you are actually communicating at the other end. We'll go over it, but do understand that how far these devices are communicating, depending on that, we will need to employ different types of devices to build the network. The another factor is the latency required. Let's say in this case it is not the devices that are actually communicating. Let's say a user is trying to access an application, and that application, an application developer develops an application or architects an application. That point in time, he actually defines what all are the latency that is actually required. A simple example would be, let's say a voice application that you are actually hearing somebody, the audio that is actually transmitted from very long distance, right? It's very important that these messages of audios, these packets of audios are actually coming in a very latency sensitive manner, because if there is a lag, then it is going to affect the way you hear those voice. So the latency is one of the factor, and along with latencies comes the bandwidth, the jitter that really impacts an application. What is latency? We identified bandwidth is basically what is the minimum bandwidth. You might have heard, like when you go to an ISP, they say like, I can give you 100 Mbps or 200 Mbps or 50 Mbps. That's actually for the home use. Now, how do you decide for an application to work? That application, for whenever there is an application that is getting built, that application developer is going to tell that this particular operations that has to be done in this application, you need minimum of so and so bandwidth. For example, Netflix, it requires a higher bandwidth because it's actually streaming high quality video, an example, right? So latency, also the bandwidth, also jitter, that kind of stuff actually really matters on what kind of devices you need to employ, because for that device, for that application to serve the purpose, it may need multiple devices as such. Another is, what is the budget allocation for running and maintaining your network? For example, let's say you are an administrator factor of a large enterprise, and there are multiple sites, and these multiple sites has to be connected. So there are multiple ways to connect these sites. It could be a leased line, which is a cable directly pulled in. It could be a technology like MPLS. It could be even a broadband. So depending on the budget, and for each of this technology to be involved, there is a budget related to it. And for each of once you finalize what is a budget and what is the type of technology you want to use, depending on that, we will be using different types of devices in each of those sites for the connectivity purpose. So budget and budget allocated for running and maintenance of your network is the next one. Another important piece is how many connections per second that you are actually trying to see. For example, let's say a retailer like Amazon, or Walmart, or somebody who's actually online who purchases. There will be huge amount of purchases when there is a holiday period like Thanksgiving, Christmas, or even if it is a site where there is some government related stuff and there are a lot of people trying to access and get the information. That means what are the number of underlying connections that is actually this application needs to, or this transaction needs to handle. Depending on that, we will be employing different types of devices, maybe a load balancer, maybe some kind of multiple devices for balancing the number of connections, and stuff like that. So that total number of connections per second is one of the key factor to identify what device needs to be employed for this network to be up and running. Another piece is what is the type of device that is actually accessing and communicating. For example, if you are accessing an application through your mobile, which is pretty common nowadays, in that case, we would need the technologies like 3G, 4G, or 5G. We call it as a radio access network. That's the kind of technology that we need to employ. Wherein, on the other side, if you're trying to access the same application using your laptop, you don't need the RAN, a radio access network, but you would need again a Wi-Fi router or a switch which is able to connect to the ISPs, and then ISPs, which is the service providers, will be able to help you connect to that particular application. So type of device and type of the end points that are trying to communicate is another factor that depends on how and what devices to be employed for building the network. And last but not least is the level of security that is needed for the sessions and transaction. For example, there may be some, your personal data that is being filled and that is being transmitted for authentication purposes, or there may be some confidential data that your company has to store in a specific location. So how do you kind of store this data in a specific location with total security? And at the same time, I also make sure that whoever is accessing my data, even that is actually kind of secure. Depending on that, you may employ a firewall and multiple features in a firewall. This list of factors that we see here is by no means the entire list. This is basically a very, very, very high level list of items that we need to consider, and depending on that, we will be deciding what all types of devices that is needed for building a network. Now, in the subsequent session, we are going to see different types of devices, and we will come back to this set of factors, and then we will see what device is the right device to be employed for building your network.